If you want to learn how to make a top-down dungeon crawler, something inspired by classics like Gauntlet and even Diablo, something that has path-finding enemies and area of effect explosions, something that was the beginning of my own dungeon crawler game, a top-down, couch co-op, action RPG with randomly generated levels and multiple player characters, then keep watching and I'll show you how. G'day gamers, and welcome back to our top-down dungeon crawler. In our previous episode, we updated the effects to make our game look better. In this episode, I want to show you a method you can use to add gamepad support to your game. This kind of top-down game works really well with a controller, as you move the player with the left stick and control the aim for the weapon with the right stick. It may even be preferred over keyboard and mouse because your movement of the player is not locked to 45-degree increments. Some games let you select the input type in a menu, either keyboard and mouse or gamepad. Well, I want to show you a method which doesn't require one to be turned off or on. But instead, whatever you are using as your input just works as the default control method. Also at the end, I'll show you how you can add a crosshair which circles around the player, showing which way you are aiming. And lastly, we'll correct a few bugs that are in our code. So the first thing I want to do is add some variables to the player's create event. So let's go to the player object. I'm going to press Ctrl-T and type in oPlayer. And I'm going to use this searchability a lot more because it just enables us to move quickly through our game when we know exactly what we're trying to find. So inside the player's create event, and just up the top, make sure you've got your walk speed set at 1.5. Now I'm going to create a new variable here, and it's going to be called move direction. And we'll just set that to 0 for now. And down the bottom here, or around in the middle, where we're setting our cursor sprite. Now we're not going to use this anymore like this. So what I want to do is change this, and I'm going to call the variable mx, and I'm going to store the mouse_x value. And that's the position of the mouse for that step. And I'm doing that so we can work out if the player has moved the mouse for that step. So we also want to add an my, and this will be for our mouse y. And lastly, I just want to add this comment. Now let's move over to the macros. So Ctrl-T, and we'll go to the macros enum script. And just in here where we're setting our states here. So what we want to do is let's add another enum. Just make this bigger. And we're going to have an enum for our controllers. And this will be the current controller that we're using. So we can either have a gamepad or we can have a keyboard. Now the value of the controller I want to store in a global variable. So Ctrl-T, and let's go to our OGame. And in our OGame objects create event, let's add a variable here for the global controller. So I'm going to set a global variable, and this will set it as global dot whatever I type here. So we want to have controller. So the controllers is the enum, controller is the variable that we're using to hold it. And the value is just controllers dot, let's set it to keyboard to start with. Now remember, enums are just numbers. So they start at 0 and then 1, 2, 3, etc. So basically we're just setting controller to this value. Now we're also going to need a few more variables. So let's go to our reset variables function. And in here is where we reset the variables for the player at the start of their step event. So we don't actually need that. And we need to create a few more variables. So I'm going to create a fire and set it to false. And then we want to create a bomb, set it to false. Now these will be the inputs. It has the player press fire, have they pressed the bomb key, have they pressed the dash key, for example. And as well as that, I want to have some variables for the movement. Now with a controller, we have a left stick and a right stick, and we have a horizontal and a vertical movement. So I'm going to store a left stick H, so ls_H, to set it to 0. Now we also need a left stick vertical, and we'll set that to 0. And then we need a right stick horizontal, and a right stick vertical. I just wanted to take a break and appreciate who makes these videos possible. Even if you want to join for free, Patreon has numerous tiered memberships to show your support. And they even introduced a free tier just to allow you to follow and see some channel updates. My legendary Patreon supporters this month are Big Honk, Jake Dowds, Mark Savage, Pillsbury, Charlie, Dennis, Anderson Santos, and Phoenix. Thank you for your generous support of my channel. It really helps me make the content I do. All legendary Patreon members receive free codes to whatever my current courses are, including this cool Mario-inspired first platformer course I've recently released. Now back to the video. Now if we go look at our player, you might recall that in the step event, you might remember that we firstly reset our variables, we then get our input, we then calculate our movement, and then we aim our bow. Now these are the functions that I want to change, and these are what we need to change in order to get the gamepad working. So let's look at get input next. So if we just move down, the last thing we have is that we're capturing the dash key. Now, so far when we fire, we've been checking that the mouse button's been pressed, and then we've been firing the bow. All I'm doing is just going here and adding variables for them, and that way we can then use them for the gamepad. So for our fire, we have left button down. So mouse down, MOB left, and we want to take a assigned variable code block, and we want to set fire to be true. Now we then have for the bomb an actual mouse button pressed because we don't need to hold it down for that one. And we want to change this to the right mouse button, and we want to set that variable of bomb to be true. Now, in order to work out if we're using the keyboard or the gamepad, I need to know, was a key pressed? So if I go down and look at key down, and I'm going to select the any key, which means if any key is held down, then whatever is under this code block is going to run. So I'm going to set a temporary variable. I'm going to call it underscore any key, and we'll set that to true. Else, if any key is not pressed, I copy, paste that here, and then drag it under the end, and we'll set that to false. So now we have a variable that is storing whether any key has been pressed. So we can use all of this information to work out, is the player wanting to use the keyboard? So if we add an if expression here, we can ask a question. And we can say if fire or bomb is true, or if any key has been pressed, or, so this covers the buttons, this covers the movement, we also need to cover if the mouse has been moved. So how do we know the mouse has been moved? How we know is if our mx variable is equal to mousex and my is equal to mouse y. So if this is true, if mx is equal to mousex and my is equal to mouse y, that means that we haven't moved the mouse. So if that's true, therefore we haven't moved the mouse, we're not using a mouse. So we need to put a not here, which is an exclamation mark, and saying if this is not true, well, that means we did move the mouse. And if we move the mouse, then we can set our global variable of controller, and we can set it to be controllers.keyboard. Now this mx variable is only set at the create event. We need to set that after this check. And that way we can use the value for the next step to see, are we still using a keyboard? So just here, make sure you drag this outside of the if expression. And we want to make sure we set our mx variable to be mouse underscore x and our my to be mouse underscore y. And I'll just add this comment here. So the placement of this is important in relation to this if check, because we're setting the value here, which means the next step, when all of this runs, if we've moved the mouse, these are no longer going to be equal. And that's why it's important to capture the mx and my values here, because we're using it the next step through to see, did they move the mouse? Have those values changed? Okay, so that's our keyboard input. I'm going to add a call parent event under here, and I'm going to disable it. And I do that because I can then add a comment, and we're looking at our gamepad input. Now there's no comment code block, so I do use this for that reason. Disable it, and you can add any comment to this, and it doesn't really affect anything else, as long as you remember to disable it. So for our gamepad input, now there are some gamepad code blocks, and the one we want to choose first is to get the gamepad count. And this code block will return the number of gamepads that can be connected to the system that you're running this on. Now in GML, it's just called gamepad get device count. And either way, we're storing the value into a temporary variable called max pads. Now I'm going to go grab a for loop. And this code block enables us to run through some code a certain number of times based on these values. So make sure you set it as temp, and we're going to run it until we get to that max pads value. So I will be set to 0, and it's going to loop through whatever we put under here until I is no longer less than max pads. And once that condition happens, it'll jump out. So once again, we're going to look at our gamepad, and this time we're going to get if the gamepad is connected. Let's drop it over on this side. Now the gamepad ID that we want to use is this I value. And we're seeing if this gamepad is connected. Now I happen to know that Windows uses 12 as its max pads value. So we're basically looping through this 12 times and seeing if there's a pad connected at that port. Now I'm going to store the variable that returns as connected, because it will return a true or false, and we'll set it as temporary. So now we can use that to say if that variable is true. So if connected equals true, then we know this pad's connected and we can do something with it. Now over in GML, we just have the gamepad is connected function, and we can check it directly using an if statement. So back on our gamepad, what are we going to look for? Well, we want to capture the movement of the left stick and the right stick. So there's a get gamepad access code block, and we're going to grab the I gamepad of the left horizontal, and I'm going to store it in those variables that we created, which is LSH. And it's not going to be a temp because these are the variables we created directly in the reset variables function. Now let's take a copy and a paste of that. And this time we want to get the left stick vertical. It's just that variable there changes, and we're storing it in LSV. Now we want to do the same thing for the right stick. So I'm going to take a copy and a paste. And this time here, we want to look at the right stick horizontal, and we're storing it in RSH. And then we want to take a copy and paste that, and we want to store the right stick vertical, and we'll store that in RSV. Now we want to know if the player is pressing the fire button. So we're looking for an if gamepad button down. And same thing, we're capturing I, and we're checking for the button that we want to press. Now we use the shoulder button, and it's actually shoulder right. And there it is there. And if that's true, what I want to do is declare a temporary variable, and we're going to capture underscore fire and set it to true. And let's add an else. And if it's not true, take a copy and a paste there, and we'll set underscore fire to be false. So the reason I'm setting it as an underscore or a temporary is because up above, we are also capturing the fire button from the keyboard press or the mouse press. So we now have a variable stored for the mouse and for the gamepad. So we need to know if one of them was pressed. So what we can do is go and add an assign variable code block, and we can do something tricky where we set fire to be either underscore fire or fire. Now this underscore one is the one we just captured here for the gamepad, and this one is for the mouse. So if either one of them are true, well then we'll store the value as true in the fire variable. And if they're both true, well, fire will still be true. But if they're both false, fire will also be false. Now, if this is new to you using or and, then you might want to look up how and or work in relation to algebra. A quick summary is if this is 0 or 0, well, then the answer is 0. If this is 0 or 1, then the answer is 1. If this is 1 or 0, the answer is 1. And if this is 1 or 1, then the answer is 1. Now we're using true or false, but remember, true or false are also 0 and 1 when we're using them in Gamemaker here. Now I'm going to use the same system to capture the bomb being pressed. So let's go back to our gamepad. And this time we want to not look at the down button, but I'm looking at the pressed. And we're looking at I, and this time we're looking at the shoulder left button. And if that's true, I'll take a copy of this, paste it here. And what we want to store is underscore bomb to be true. Let's take a copy and a paste of this. Else our underscore bomb is false. Now the same thing, we'll take a copy and a paste of this. Our bomb is either underscore bomb or bomb. Now we need to do the same thing for the dash. Now in visual, the dash is a little bit different because it uses a trigger button. So there's a left and right trigger on your gamepad. So we need to use the get gamepad trigger code block. Once again, setting it to I. And this time we're capturing the left trigger. Now, I have no idea why Gamemaker does this, but left trigger is stored as a variable shoulder LB. And as far as I know, the gamepad trigger buttons are the ones you use with your pointer finger. So I believe that this is a mistake in their situation. I really think that this should not be LB because we're looking at a trigger button. It's the one with your middle finger. And these are the analog buttons. And that's why it's a little bit different because you're capturing them as an analog value between 0 and 1. But just be aware of this because the shoulder L is actually the button, whereas the shoulder LB is actually the trigger. And yeah, it's confusing. I don't know why they did it this way. So we want to capture the value into underscore dash, and I'm going to store it as a temporary. And once again, I'm going to go here, copy and paste this down here, and we're storing our dash value as a little bit different here because it's a value between 0 and 1. So I need to say underscore dash is not equal to 0 or dash. So if it's not equal to 0, that means you're pressing it somehow, even a little bit, then we want to set it to true. Okay, so that's captured all our bomb, dash, and fire buttons. Now the last thing we need to know is the controller being used? Well, if any of those buttons are being pressed, then the answer is yes. So what are we going to ask? Well, if our left stick underscore H is not equal to 0, or our left stick underscore V is not equal to 0, or our right stick underscore H is not equal to 0, or our right stick vertical is not equal to 0, or our underscore fire, or our underscore bomb, or our underscore dash. If any of those are true or not equal to 0, so if any of this is true, right, that should be ls. If any of those are true, then what we basically want to know is we want to exit if the controller was used. So if that's true, we're going to declare a temporary. We're going to use our temporary variable of I. And we're going to jump out of our loop by setting I to be max pads. And by setting I to whatever the value of max pads is, it means that it won't loop anymore. That's the end of our loop. And lastly, we want to set that global variable that we have called controller to be controllers.gamepad. Okay, so there's a huge amount there for our get input. So I'm just going to go back at the top and just show you there what we have. So we added everywhere from mouse down of the capturing here. So I'm just going to go through that so you can see if there's something you're missing. Now here's our loop. Now here's our capturing of our shoulder buttons and then our trigger button. So now that we've captured all of that, we need to apply it in our calc movement. We need to work out if we're using a keyboard, what do we do? If we're using a gamepad, what do we do? I just wanted to pause for a moment and thank the epic supporters for this video. They are Chris LeBlanc, Dennis Evans, Alex Wachowski, Joseph Camello, Marlo Dobby, Jargon P, Logan H, Stephen Givens, Dank Dan, Baba Satar, Jack Budgeon, Hercule TV, and Liz Dora. Thank you so much for your support. As well as tutorials and courses, I've also been working on a few games. One of those is Tank Dash. Now this is a fun couch co-op game, and there's a page up on Steam. Now the way Steam works is it promotes games that have high wish lists. So even if you're not interested in purchasing the game, and you appreciate the content that I give you, if you can go over to the link in the description and just wish list this game, it's free to do so, but it'll really help me out. I also have a few videos on the channel showing some of the Bullet League gameplay if you want to go check them out. Now let's continue. So let's go to our calc movement function and just in here. So this is all set up to use keyboard only at the moment. Let's put a check here and let's see if our global.controller is equal to controllers.keyboard. And if it is, well, then we can use our keyboard controller as normal. So I'm going to take this and drag it over here. And for the moment, that's the only one I'm going to place in there because the facing changes are not going to be affected by what controller we're going to use. They're just going to work no matter what we do inside these if checks. So I'm going to leave these alone for the moment. I'm going to go down and grab this if expression because this is where we set the movement for the keyboard. I'm going to take this and let's just drag it underneath that assigned variable code block. So we're still doing the same check here, except I'm just going to make one change here where we're doing our point direction, where we're working out which way we're moving. I'm going to set the move direction. Instead of _dir, I'm going to set it to our move_dir variable directly and make sure you take off the temp. Now this is the one we created in the create event. And I'm basically storing that so that when we do a dash and we're not moving anywhere, it'll remember which way we last moved and it'll dash in that direction. So it's kind of a fix why we're working on this. So now we need to use that move_dir variable just here and also just here. So that's all we need for the keyboard. Now I'm going to take this and drag it just above our declare facing because we're not applying that yet. We need to work out the gamepad movement first before we apply that. So we need to put an else in here. Right under the check for the keyboard, this is all our keyboard. And if we're not using a keyboard, well, we're using a gamepad. So this is our gamepad movement, whereas here is our keyboard movement. Now I'm just going to take a copy of this assigned variable code block and just paste it here and make sure we drag it under the else on the right there. And what we want to do is our left control stick. So we still need to set these values of hmove, but this time we're using it based on the ls variables that we captured. So our lsh times our walk speed. So this value is -1 if we're moving to the left, it's +1 if we're moving to the right. But because the sticks are analog, it can be a value between -1 and 1, a decimal value. So by doing it this way, we can actually move a smaller amount if we're only moving the stick a little bit. And the same for this one, we want our LSV and we want to times that by our walk speed. Now experience tells me if you do this, when we move left and up, so at a diagonal, you actually are moving much faster than you are moving when you move left because you're getting the combination of the horizontal and the vertical combined. So for a top-down mover, you first need to normalize the vectors, which means ensure that you can't move faster diagonally. So I'm going to take a function call here, and I'm going to get the square root of hmove times hmove plus vmove times vmove. Now, I'm not really going to go into the mathematics of how all this works, so I'll just add a comment here, and we're going to use this to normalize our vectors. And I'm going to store the value in speed or underscore speed and store it as a temporary value. Now, this is not the end of it, because we then need to do a check, and we need to say if that underscore speed value is not equal to 0, then what we can do is assign hmove to be hmove divided by speed, and vmove is going to be vmove divided by underscore speed. Now, underscore spd, make sure you're using that. Don't use the variable speed, because that's a built-in variable. It won't work. I'll add this comment here. And we'll basically use this to ensure we never walk faster than our max speed by setting our hmove to be hmove times the minimum of our speed or our walk speed. And I'll take a copy and a paste of this, and we'll set our vmove to be the same. So this way, we're never walking faster than our walk speed value. Now, the last thing to actually check for is, was the player attempting to move? So if our hmove plus our vmove is not equal to 0, then yes, they were trying to move the stick and move the player. So we can look at our point direction, and point direction takes one set of coordinates and another, and it will give you the direction between them. And in this case, I'm going to set it from the point 0, 0 to hmove vmove. And we'll store that into our move direction variable. So 0, 0, remember this is a value between -1 and 1, and this is also between -1 and 1. And if we work out the direction from 0, 0 to that, it'll give us a direction that we are attempting to move. So basically, we're setting the move direction. Now, the gamepad input is a little bit more complicated, but it's because we are normalizing those vectors to ensure that it's accurate and we don't move faster diagonally. A lot of tutorials might miss that out. It's actually really important. So once we've done that, we can then apply that hmove or vmove directly to our x and y, just like we had before. And all the rest of our code still applies just like it did before. So let's make sure we save that, press play. Our keyboard movement still works like it did before. We can still aim and do everything we did. And if we grab our gamepad movement works just like it did before. So you can still zoom and dash. What you can't do is aim or fire, but you can still dash, and the movement diagonally works just like we had it already. So let's add the movement for the bow. So let's go to our aim bow. And I'm going to make a few changes here, actually. So the first thing I'm going to do is create a temporary variable. Just drop that above the assigned variable code block. And I'm going to call it _dir, and we're going to set it to undefined. So not 0, but undefined. And that's because if we don't get a value for this, then it means that we weren't trying to move the bow. So let's do a check. And depending on which controller we're using, so if global controller is equal to keyboard, controls.keyboard, then if that's the case, I'm going to use our point direction, and this time from our X and Y to our mouse X and mouse Y. And we're going to store the value in _dir. So we're just working out if the player is using the keyboard, what is the direction we're aiming. And let's add an else here, which means we're checking the gamepad. And this time we're looking at our right stick horizontal, and we're adding that to our right stick vertical. So if you add them together and they are not equal to 0, it means we were trying to move the right stick. We were trying to aim. So if that's the case, I'm going to take a copy of that, paste it down here. But this time we're going from our 0, 0 to our right stick horizontal and our right stick vertical. And storing that in that dir temporary variable. So now that we've captured that, we need to check if we had a dir variable. If it's not equal to undefined, it means we tried to aim. So if underscore dir is not equal to undefined, then yes, we are trying to aim. And what we want to do is move our aim to whatever that direction is. But I don't want to snap it there. I want to move it slowly. So I'm going to use angle difference. And this takes a destination and a source, and it'll give you the difference between the two angles and the difference between our aim dir and our underscore dir. I'm just going to store that in a temporary variable called diff. And the reason I'm doing that is whatever the difference is between the two, I only want to move a small amount. I don't want to move the whole way. So I'm going to set our aim underscore dir variable to whatever our aim dir is minus the minimum of our ABS of underscore diff or 10. And I want to times that by the sign of diff. Now that might seem a little complicated. We just need 2 brackets in there. But basically what we're doing is whatever the difference is, and I'm taking ABS, which means it's a positive value, the difference, we're looking at the minimum of that value or 10. So whichever value is the smallest. So it won't move any more than 10 degrees at a time. And then I'm timesing it by the sign of that to ensure we move the correct direction. And we're minusing that from the direction in order to move to the new value or the new direction that we're aiming at. So we don't need this aim direction check anymore. And the last thing we want to do is make sure our aim direction is between 0 and 360. Because when you increment an angle in Gamemaker, it can keep going higher than 360 because angles in Gamemaker are not set to stay between 0 and 360, but it is easier for us to keep it in that value when we're doing our checks. So what I want to do is check if aim direction is greater or equal to 360. And if it is, then I'm going to set aim direction to be minus 360 relative, which means we take off 360 and just set it back to the value between 0 and 360. And let's add an else here. And we'll do another check and we'll say if aim direction is less than 0, then we want to do a similar thing. We want to take aim direction and we want to add 360 to it. And that way it'll always stay between 0 and 360. Now, before we test that out, let's go to our check fire because we need to ensure that we are using the newly set variables to fire and to fire our bomb. So in here, we are checking if we're pressing the mouse button. But as we know, that's not always true anymore. So instead of doing a check like this, we can drag over an if variable check and just place it above. And we can look for the variable fire directly. Now, if that is true, then the player is trying to fire. We want to do all of this. So let's just grab that and drag it up the top here. And we can get rid of this code block. Now, the other thing we need to check is just here where we're capturing the direction that we're aiming. We no longer want to check between X and Y and the mouse. Instead, we can set this directly to our aim underscore dir variable, and then we'll use that down here. So let's do the same for our check bomb. And this is exactly the same. We are taking an if check and we're checking for the bomb variable. And if that is true, then we want to take all of this and place it here. We can delete this one And the same thing as before, we're not looking for the direction anymore. We're referring to the aim_dir variable. Now, the last thing is for our check dash. Now, we realize that this worked before, so I think we're okay with this one, but we do need to make one change. And that is just down here. We now no longer need to capture the direction we're moving because we're storing that in our move_dir variable. So here we can delete this, and right here we can change this to use our move_dir variable there and there. So let's press F5 and test that out. So now when we move, we can aim with our bow, we can fire in the right direction, and we can throw our bomb in the direction that we're aiming. We can also dash in any direction. Now, if I swap over and I use the keyboard, it all still works. I can still aim. It's just that I don't have a crosshair showing me where I'm aiming, which does make it a little tricky. But you might also notice something, and that's when I go near a wall, I can push diagonally towards a wall, and I can sort of cheat by going a lot faster than I should be. And that works with keyboard or with controller. So let's go make a little change to fix that up. So let's go to our collision function. And just in here, there's a change we can make to fix that up. So down here, where we are getting the max distance we want to move, instead of ceiling, we're going to use floor for both of these. And once we make that change, we actually don't need any of this below. So this if object at place or if place meeting, if you're in GML, we're going to take that out and take the second one out. So if we test that now, you'll see that you no longer speed up when you go against a wall. It'll just go the same distance or the same speed as normal. It actually slows you a little bit because you're pushing into a wall, so it should slow you. And that works great. Now, the other thing we talked about was getting a little icon on the screen so that you can see which way you're aiming. Now, we want to draw the aiming cursor in front of the player so we can see where we're aiming, but we only want to do that when we're using a gamepad. Also, we need to draw it on the GUI layer, which is a special layer that floats over our game. We can use it to show the score or UI, so user interface elements. It is also not affected by the camera movement. So all coordinates are based on 0, 0, which is up the top left of the screen. For that reason, we need to do some calculations with the camera to find the player's position so we can then draw the cursor at a distance around them. So let's go to OPlayer and let's add a new event called a draw GUI event. Now, the first thing I'm going to do is check if we're using a keyboard. So let's look at our global.controller. And if it equals controllers.keyboard, then we are using a controller. And all I want to do when using a controller is assign that cursor sprite variable, which we took out earlier. And we want to put the cursor sprite back in. And I'll just add this comment. Now, the other thing is if we have an else, then we're obviously in gamepad control. And if that's the case, I'm going to take a copy and a paste of this, make sure it's under the else. And we're going to set our cursor sprite to be CR_none, which means you won't show the cursor sprite. And I'll just add this comment. Now, the math here is a little tricky because we are basically finding the position of the player relative to the GUI. So the first thing I'm going to do is get a temporary variable called _ratio. And here I'm going to capture the display get GUI width. And I'm going to divide that by the camera get view width. Now the current camera is called view_camera 0. So we'll just add a comment here so we know what's happening. And now that we have that ratio value, I'm going to disable this. And here we're going to get the player's X and Y GUI position. So another temporary variable. And here we're going to call it underscore XG for GUI. And this is going to be the value. And we'll just add a comment so we're aware of what we're trying to do here. Now I'm going to take a copy and paste of this. And this time we're getting the Y GUI value. And it's the same thing. It's Y minus the camera view Y times the ratio. So the values stored here are basically the player's position relative to the GUI. Because the GUI starts at 0, 0 up the top, so no matter where our camera is on the screen, if we're right down the bottom right of the game, the GUI's position up the top left of the screen is always 0, 0. And these values now represent the player's position relative to that 0, 0. So these values will only ever be between 0 and the width/height of the screen. So now that we have the player's position, we can actually draw the targeting around the player. So I'm going to declare a temporary variable, and this is going to be our length. So the length from the player that we're going to draw the target. And I'll just add this comment. And this value will just be the distance from the player we're going to use. And we're going to store a temporary variable, going to call it underscore X. And this will be the X position we're going to draw the target at. And all we want to do is take the player's X GUI value and add length to X of our length and our aim direction. But I'm going to round it so that we don't end up getting any jittering with our value. Now we need to take a copy and a paste of that. And we do the same thing for the Y. Underscore Y is going to be our underscore YG, and it's our length de Y. So now this underscore X and underscore Y is the exact position that we want to draw the target. So let's go to our draw, and we want to draw a sprite. And we want to draw that cursor sprite directly at underscore X, underscore Y. And that should be all we need. So if we press F5 and test that out, we now find that we have an aiming target just in front of the player. Makes it a lot easier, and it doesn't really bounce around. It's pretty stable. Depends on your controller. If your controller jitters a little bit, you might feel it's jittering. So now if we move the keyboard and the mouse, well, we have a target again, but it doesn't stick around the player. It's actually much easier not to have that happen when you're using the keyboard. So the other thing you might notice is if the bow is down low, you can see that it sits in front of my player. When it's up behind, it's behind the player, which is right, but down low, it should be sitting in front rather than behind. Now, if your one does the same thing, you can go to OPlayer, and you can go to the end step event. And just here where we're doing our check, I'm going to change this. And instead of doing it that way, I'm just going to look at our aimed and say if it's greater than 0 and aimed is less than 180. So that means that we have the mouse up the top. If that's the case, then I'm going to set a temporary variable of underscore depth to be 1. And that way we're going to add that to our current depth and it'll draw it behind the player. Else, I'm going to store that depth value to be -1. Now we don't need this here anymore. And here is where we use that. And that should fix that problem. So press F5 and we should see that now the bow stays in front of the player and behind the player when it goes the other way. Lastly, I want to correct the problem with the knockback. Shout out to Discord user Parker who noticed this problem. So if you're not part of the Discord, join us over there as we discuss coding, we showcase our games, and I also show off other projects I've been working on. So the issue is we are using the knockback time variable to tell us how long we should stay in the knockback state. But also the enemies use the same variable to set how long to put the target into the knockback state. So the player does not actually get placed into their knockback state for the right amount of time when they get hit. To solve it, we need to add another variable for how long to place targets into the knockback state. So very quickly, let's go to enemy parent. And just here where we're setting a knockback time, this is how long we are knocking the player back for. I'm going to change this variable and we're going to call it knockback target time instead. Because knockback time is actually being set in the entity parent, and this one will be for how long we place the player in their knockback state, and I'm going to set it for 15. So now we have that variable. When the enemy creates an attack, we need to pass that value to the enemy hitbox. So if we just do a search, so Control T, and let's search for our perform attack. So right here. And where we perform the attack, where we pass the variables through, which is just here, instead of passing back the knockback time, we can actually pass the knockback target time variable. So we're passing the enemy's knockback target time variable to the instance of enemy hitbox and storing it in the enemy hitbox knockback time variable. So therefore, that will then apply to the player when they get hit. So if we test that now, when the player gets hit, we'll notice that they can't move just for a bit of time. Why that? You can see them actually moving and not getting hit. Now, if we go to player, if you ever want to test things, test variables, for example, you can go to the draw event, and then down the bottom here, you can just draw some text. You can draw a value, and you don't really need a caption, but you can draw the value of, say, state for the player. And here we'll put it at the player's position, at their X and Y, and just 10 below. So now you can see the state that the player's in, and you can see that it's 0 by default. And when we get hit, it changes to 4 for a period of time. And that's the knockback state. If you showed this before that change, you would see that it stays at 0 pretty much all the time. It's only goes to knockback very quickly, literally for one step. So I'm going to just disable this. You can actually use this later on if you need. Now for the player who doesn't use a knockback target time on their arrows, so if we look at the arrow create event actually has a knockback time by default, and we're setting it here. But I think it's better if the player also has a knockback target time, because you can make different weapons have different knockback times. And if you have the player picking up power-ups, for example, they could have a weapon that has a larger knockback time. So just in our player, in our create event, so just where we are setting the arrows, so up here where we're setting arrow speed, I'm going to add another variable related to our arrow, and I'm going to call it knockback target time. And I'll just set it to 5. And then when we create the arrow, we need to pass this value through. So let's go look at our check fire, which is where we are creating the arrow. And just down here, where we're creating the arrow here, and then we're assigning some variables to it. So just here, where we're assigning the owner ID, let's also assign the knockback time variable to be other.knockback target time. So that's now going to grab the player's knockback target time and assign it to this knockback time variable, and that'll overwrite the arrow's default value of 1. So now when we shoot the bow, we'll get the enemies having a bit of a longer knockback, because we had it at 1 there before. But you can then set different values. So for example, if I jump back to the player and we set that knockback time to say 20, you'll see that the enemies get hit and they stay knocked back for longer. So maybe you could have some weapons that actually had longer knockback times. And you can see there how long he's staying in knockback for. I'm going to leave it at 5 by default. This has been a long video, but adding gamepad input the correct way does take time. Creating these videos at the level of quality I do takes a huge effort. And if you've made it to the end, it means you must have appreciated the content I put out. Patreon has a free tier where you can follow my game dev journey and also pick up any helpful posts I put on the site for those free tier members. Thank you to these rare supporters for this month, but if you want to see more of my content, there are also other tiers where you can contribute to help support the channel. If that's not for you, then at least subscribe to the channel because that also helps. Thanks for watching. I'll talk to you in the next one.